Hi, this is Ben Nelms from Canis Lupus. There are a host of side benefits to using a vendor-neutral software application, such as quality reports, to read, analyze, and document your TPS output. One of the surprising benefits is in the realm of quality assurance of the DVH statistics generated by your TPS. Another is to audit the veracity of the DICOM files exported by the TPS, which Quality Reports does by its very nature as a window into the complex DICOM and DICOM RT data objects. But let's discuss more fully how valuable it is to do independent checks of DVH generation, and then explore an intuitive and powerful tool built into Quality Reports that's dedicated specifically for this task. In 1998, when 3D treatment planning systems were used by more and more sites, the AAPM Task Group 53 published an article called Quality Assurance for Clinical Radiotherapy Treatment Planning. In this comprehensive document, many requirements and tests were suggested as a basis for commissioning treatment planning systems. Among them was a suite of tests to verify the accuracy of DVH statistics. However, test tools for DVH were never commercialized, and as a result, over time, it was expected that TPS vendors would do all the required testing. And therefore, over time, treatment planners and physicists grew to assume that their TPS values were always correct. Well, as it turns out, this is not the case. There is not only inter-TPS variation in the methods of DVH, but intra-TPS variation due to the different DVH settings and preferences that many treatment planning systems treatment planners may not even know about. Dose binning, dose interpolation, structure, voxelization, and DVH binning are some of the variables that are core to generating DVH statistics. Consider DVH bin width, illustrated here. Dose points are binned, that is, counted, into applicable dose regions. The bin width is the dose increment where close dose values get counted in the same bin. Dose bin width determines the resolution of the DVH curves. Smaller bin width yields higher resolution and is more accurate, especially when there are high gradients in the 3D volume. In some instances, the DVH sampling grid is not aligned with the actual dose grid, and interpolation errors are possible. For instance, as illustrated here, if a separate DVH sampling grid is used, it can miss the highs and lows, that is, the peaks and valleys of the dose matrix, resulting in data loss and impaired DVH statistics. Take this real-world example. A customer's treatment planning system recorded a max dose into this structure of 24.84 gray. However, the quality report software gave a max dose based on the exact dose grid and structures in the DICOM RT files of 29.01. That's a big difference. Under close examination, the dose grid point at 29.01 gray was easily identified as being inside the structure, as correctly tallied by the quality report software. However, due to coarse DVH binning that was set in the treatment planning system, this dose grid point was completely missed by the TPS DVH sampling. Quality reports identified this issue, and the customer was able to reset the DVH preferences in the TPS to improve its accuracy. But without quality reports, this user never would have known that there was even an issue. So here we are in the quality reports software where I've loaded up an IMRT plan to a brain lesion. You'll notice here I'm on the DVH tab, and on this tab there is a button or a tool called DVH QA. And this is precisely the tool that we're talking about. If I activate this, what I can do is load up any of the structures. So just for sake of example, I'll pick the brainstem. And then shown on this are the statistics as generated by quality reports, given the DICOM RT dose and structure sets that were imported. Now I've gone to the planning system, in this case which was Eclipse, and I have extracted some of the DVH points and basic statistics. Now I can enter those points for direct comparison with the independently calculated quality reports values. So for example, from Eclipse, I got the minimum dose to be 4.24, the mean was 19.66, the max was 48.4, and the volume was 31.4 cubic centimeters. You can see then an absolute difference and a percent difference between quality reports and the TPS are shown here. And all the values are extremely close, all within 1% except the absolute volume, which was just a hair over 1% difference. So you get immediate quantification. But more than that, you can actually check points along the DVH. I've gone through here and I've extracted a few points from the eclipse curves. On one point I extracted was 10.01 gray, and the volume was 74.3. You can see here a black dot shows up to be exactly the point from the TPS curve, and you can see here it overlaps with the blue curve. Quality Reports calculates a closeness factor, which is kind of like the percent difference distance to agreement, where it finds the closest pathway either in dose difference or in volume difference to get to the curve matching. You can see here the closeness is well within 1%. Let's try another point. 25 gray from the TPS, I got 32.4%. And again, you see here the closeness well within 1%, and in fact the point overlaps. You can do this for as many points as you want. Finally, I've picked a point on the tail, and you can see here also the closeness within 1%. And so you can really plug in as many points as you want and get these absolute comparisons, generate reports, and the report pages can be used as part of your TG53 protocol. This makes your life very easy and gives you the peace of mind that you've audited your treatment planning system DVH statistics.